Ah, well, today we're going to be talking about Z offsets, or basically the height which your nozzle is when it prints the first layer, which is obviously very critical in having a successful print that sticks to the bed, etc, etc. I've been asked about this by a few people via emails. So I'm going to do my best to explain what's going on and how I do this. Now, there are lots of different ways that you could do it, and believe it or not, I've actually kept this as short as I possibly can. There's so many details that I could discuss that it could have worked out even longer than it is. But so I'm trying to keep it down to... In my case, I'm not really happy to just set something to a figure and hope for the best. It kind of concerns me that it might not be right, or if something goes wrong, I won't really know what's going on. So, for me to understand something, I need to see exactly how it works. And I'm hoping that this video will help you do the same for this particular subject. Now, if you're wondering how I managed to make a video over 30 minutes long about setting your Z offset, well, let me demonstrate. Before I get going on the actual process that I'm going to use, I'm going to run through a few sort of little sticks in the ground and some considerations, and just cover some ground before we get stuck right in. So we're going to be talking about Cartesian based machines, which the Prusa, amongst many others, fall underneath. This is where each axis moves individually, and the Z-axis is the nozzle moving down to meet a effectively stationary bed in terms of vertical movement. The same principles apply whether it's any type of machine like a Core XY or anything else, except you're just going to implement it quite differently. We're also talking about machines with a proximity sensor, a Pinder probe, or whatever you want to call them, which is effectively a sensor which can detect when a lump of metal gets within a certain distance, and then it triggers a signal. So there's two ways to look at this. Either you're starting from a brand new machine, or you're going to be starting to recalibrate a machine you've already done. In either case, well, if you're starting with a new machine, everything's probably at zero anyway. But if you've got issues with your Z height or your nozzle clearance or whatever you want to call it, I do suggest that you zero all of the settings that we talk about, and maybe any other settings that might be affecting the Z height in both the firmware and any slicing software. It's also worth mentioning that I think it's best to have your final print surface ready before you start any of this. If you make all these measurements and then you sort of stick some blue painter's tape on top, or Kapton tape, or whatever else it is, of course you are ending up affecting the distance between the nozzle and the actual print surface, which is what's critical here. So I would definitely suggest that you go ahead and put your final print surface on. In my case, I'm using Kapton, but whatever it is, put it there first. So in this video I have to focus on Marlin firmware, as that's basically all I've got, and I don't have the funds in order to go and buy lots of different printers, and certainly nobody's throwing them at me for nothing. So I can only really demonstrate what's available to me, and that is a 3D printer. In fact, pretty much a Prusa i3 Mark II clone using Marlin, and that's what I'm going to be talking about the rest of the way through this video. This happens to be the same config that the few people that have asked me about this particular subject have, so hopefully it's relevant to them and relevant to most other people. I would say that as far as I know, you're going to have pretty much the same options no matter which firmware you're using. So inside Marlin's configuration file, which is called configuration.h, there really are only three particular parameters that affect your Z height or your Z offset. The first of these is the Z probe offset from Extruder, and this is the one that we're going to focus on pretty much entirely. At least for me, it took me a little while to get my head around exactly what it does. This is where we are actually going to set our complete Z offset, and the better way to think about this is the distance between where your probe triggers, i.e. nothing to do with the physical tip of it, but where it's actually triggering when it comes down and sees the metal of the heated bed, from that point down to the bed itself, minus some little clearance for safety reasons. Anyway, we're going to be discussing this one a lot. The next one, define Z min pos, and it currently set at 0. Basically, this is another opportunity for you to put an offset in, and I recommend that you just leave this at 0, and we'll make all of our changes on the one above, the Z probe offset from Extruder parameter. So just leave Z min pos at 0. Another parameter in configuration H file that we need to be well aware of is the min software end stops. And when this is defined, what it will do is it will prevent the nozzle or the Z axis moving any lower than the point at which you've set up your 0 point. And in most cases, when we're actually running the printer, we want this parameter defined so that it does prevent the nozzle moving down further and possibly hitting the bed. But there are times during this calibration of the Z axis where we will need to disable this by commenting it out and re-uploading the firmware, so that we can actually move below 0 when we need to during this process. There are also some settings in all of the slicers that I know of, albeit in different places in each slicer and maybe with a slightly different name, but they all have the ability to add additional offsets to your Z axis, and by and large we will need to be using those, but again, as with everything else, when we start out this process, it would be best to have a process or a profile or whatever it's referred to in that particular slicer with it all set to 0. And finally, before we get going, I would just like to say that you know, we've already discussed a few different parameters above that we can set. There are probably more, which means that there are so many permutations about how you might do this, and there is no right way. At the end of the day, the right way is when the print comes out and does exactly what you want. So what I'm demonstrating here is just the way that I do it, and yeah, so let's sort of get stuck into it. I decided the best way to sort of display what's going on here is to use some graphics, and maybe even in some cases some animated graphics. Yeah, I did initially try to do it sort of with the actual machine, but it's a bit of a fool's errand because yeah, lighting, the parts are small, the gaps are even smaller, so this seems to be the best way of doing it. So yeah, let's run through how I set up the nozzle, and first of all let's have a look to see what issues there are if it's not possibly done in what might be considered the right way. So you'll probably hopefully recognize that we have a nozzle on the left there and a probe on the right. And that sort of red semi-transparent triangle is representing the beam area of the probe. When the very bottom of that senses the bed, it triggers the probe, and that's what we would call our machine 0. Basically, it's hit the Z lower limit. So I'm going to assume you've already set up the probe height. Essentially, all you need to take care of there is that the probe is sensing, i.e. the red triangle area touches the bed before the actual nozzle does, and to basically then maximize the distance between the tip of the nozzle and the tip of the probe so it doesn't get in the way when you're actually printing. So let's run it with any Z offsets in both the firmware and possibly on your LCD set to 0. So when we home the Z axis, the Z carriage is going to move down until that red triangle touches the bed, and we can effectively say that we've hit the Z minimum limit. So obviously we now have a distance between the bed itself and the tip of the nozzle, and I've marked that up as L here, and as you can see, L is effectively arbitrary. It's just whatever you set it up, whatever you were comfortable with when you set up the height of your probe. It's probably going to be somewhere around about 1mm to 2mm. It just depends on how you set it up and what the reach is on your probe. Now obviously we need to do something about the height of the nozzle here, because it's some way from the bed, like I said, between 1 and 2mm maybe, or more or less, who knows. This is kind of where things start getting a little bit confusing in some cases. There are different bits of information around on how to do this, which may or may not be correct, and they may also be misunderstood. So what I'm going to show you is my way of doing it, and first of all we're going to show what the potential problems are if it's done in a different way. So one of the sort of common things that's bandied about is by using a piece of paper or a folded piece of paper, and so we're going to give that a go first of all. And as you can see, I have represented my folded piece of paper by these two grey bars. And we're going to slide these two grey bars, i.e. our folded bit of paper, in between the bed and the tip of the nozzle. So obviously the folded bit of paper has a height, and the distance between the bed and the top of that paper is going to be effectively unknown. You could get a micrometer out and measure it, but yeah, probably not going to do that. So that's one of the kind of little issues really, is paper. Yeah, there's lots of different types of paper. So we're going to say that your gap there, the L1, is somewhere between 0.05mm and 0.3mm, depending on how many pieces of paper you put and how thick that paper is. So it's effectively unknown. We also have another distance that we're looking at here that I'm calling L2, and that is the distance between the top of those two bits of paper and the very tip of the nozzle. And of course, as we don't really know how high the nozzle was from the bed, nor do we know how thick those two pieces of paper are, obviously L2 is completely unknown at this stage. So our job now is to get the tip of that nozzle to come down and just reach the top of those pieces of paper. So there's a slight amount of resistance when you try to slide them around on the bed. Now there's two ways of doing this, and depending on how your printer's set up, you may have to do it the hard way. What you can do is you can go into your firmware, and I'm just going to limit my discussions to Marlin, and you can fiddle around with the Z probe minimum offset that we discussed at the beginning. The other way of doing it, which is going to be a lot quicker and a lot easier, because otherwise if you do it in the Marlin configuration H file, you're going to have to update the file, reflash the firmware onto the board, and yeah, restart everything up. And that's going to be a long trial and error process. So the better way of doing it is, if you've got an LCD, is to use that and go into the menu there, go down to Control, and then into the motion settings. And you can see that you can change the Z offset by winding the dial backwards and forwards. You can change that, and the probe will move up or down, and you just adjust it until you've got a sort of just about a little bit of resistance when you try and slide the paper around underneath the nozzle. So let's say that our Z offset ended up being minus 0.75. The next time we home the machine, the Z axis is going to move down until the probe senses the bed, and then the machine is going to know that it's 0.75mm above the actual workspace 0, or G-code 0. So if we use Prontoface or whatever else you're using to control the machine and do a G0Z0, what will happen is that the Z axis is going to move down 0.75mm, and the nozzle should end up in a position where we get that slight amount of resistance on the paper. So what we've done here is set the G-code 0 to 0.75mm lower than where the probe triggers, but effectively because of that unknown thickness of the paper, we're still at an unknown height above the bed. But we're going to call this our G-code 0, and this is what we should enter now into the Marlin configuration H file. Under the Z probe offset from extruder parameter, we set it to minus 0.75 or whatever we had to set on the LCD to get it to just touch the top of the paper. So assuming that we've set everything else up on the printer, we are kind of ready to do a print now. So I'm just going to do a very quick example in Simplify 3D, export some G-code. We'll open up the G-code and find the first Z height instruction. So you can see the first layer here, which is in fact the skirt, which will be basically at the first layer height, is the Z height is set to 0.2 millimeters. And I guess I should have mentioned that the process I'm using has a 0.2 millimeter layer height, with a first layer also at 0.2 millimeters or 100%, depending on the slicer that you used. Now the important point here is that this 0.2 millimeters is a G-code value, and that's the reason why I called the zeros we've been looking at machine 0 and G-code 0. So this 0.2 millimeters is 0.2 millimeters above G-code 0. So I expect you can probably guess where this is going, but we'll go back to look at the graphics and have a look at it in more graphic detail so we can see exactly what's happening. So our G-code 0 still remains at basically an unknown height above the bed. It is equal to whatever the paper thickness was that you used to set it at. Just so we can put a stick in the ground, I'm going to call it 0.15 millimeters. So effectively what we've got as our first layer height is a 0.15 millimeters plus 0.2 millimeters. In my math world, that equals 0.35 millimeters above the actual bed, which is almost double the 0.2 that we actually wanted. So at this stage, you know, if you maybe didn't know better, or yeah, whatever, you might go ahead and try a print. And of course you're going to have first layer adhesion issues amongst other things. So then what would happen is you'd sort of start down the route of trying to fix this, or probably scratching your head wondering what's going on in the first place, and then go down the road of trying to fix it. And of course we can come back and look at some of the parameters that we've set already in configuration H file in Marlin, or whichever firmware you're using, the general offset, the Z offset, sorry, in whichever firmware you're using. But more likely you're going to start tweaking things in the slicing software. Now all of the slicing software that I know of have the ability to build in a sort of Z offset if you like, to further tweak the height of the nozzle as related to G-code 0. And I'll show you the places, in fact there's usually more than one, where you can tweak this in Slick 3R or Slicer, whichever you want to call it, and also Simplify 3D. So let's take a look at those two bits of software and see where we might start tweaking this value. So starting off in Slicer or Slick 3R, we'll have a look at where you can affect the Z offset. Now bear in mind that basically all we're ever doing here in any of the settings, whether it's in your firmware configuration or in the slicer, is we are adjusting the height of the Z axis, so it can only move up or down. So there are a number of settings which affect that, and it's really just dependent on, let's say, the timing of when it makes that setting applicable, or really just common sense and keeping things straight in your mind. And the reason why I say that, and if we go into the printer settings, sorry, the print settings, you can see that what we could do is we could set the first layer height to a much smaller amount. And of course, you know, everything else being equal, that is going to make the Z axis lower when it prints the first layer. So that's one way of doing it. I really don't think it's a great way of doing it. Well, for me, it's not a great way of doing it. I would rather keep my first layer height to an actual figure, so I can sort of see what's going on and relate to that, because if we put in a fake number here, it's not really printing at 0.2 millimeters above the bed, and if we put it down to 0.05, it's that's not really the first layer height. You're sort of covering up a gap that's somewhere else. So in Slick 3R, the place to make the setting is in the Printer Settings tab, and you can see there is a field here called Z Offset, which enables you to do exactly what we want to do. You can put a negative figure in there, and basically it's going to treat all of the G-code will have that amount subtracted from what would normally be output for the Z-axis. So if your first layer height was 0.2, and you put in minus 0.1 here, your actual first layer height would be 0.1 millimeters from the bed. Everything else being considered equal. Bear in mind, we don't really know what the height is at the moment, so you're just going to be tweaking this up and down until you get a happy situation. So really, you know, this method is trial and error. Obviously you can't go crazy with it because you'll probably, well, there's a little issue that we'll come to in a minute, but basically for now, let's just say you don't want to end up smashing a nozzle into the bed. So you're probably going to tweak this down by, you know, 0.02 millimeters at a time, run a print, or at least the first layer of a print, see how it goes. And yeah, basically repeat that situation until you've got a nice sort of squished first layer that adheres to the bed quite well. Okay, so moving on to Simplify 3D. Now, you know, Slick 3R and Simplify 3D take quite different methodologies on how you make the settings, and neither one of them's ideal for me. But anyway, that's a subject for another video, I think. What we can do, and one of the first things you're going to do when you've just set up a new printer or anything else, is you're going to go in and you go into the options and go onto the machine tab, and you can see that we've got some settings here, and these are, you know, the extents from 0, G-code 0 for my particular printer, so that's probably not relevant to you. You can also do some origin offsets and toolhead offsets. Now the toolhead offsets only deal with X and Y axis, but what you could do is play around with the origin offset for the Z axis. But I don't really recommend you do that either, because this is going to be fixed for the printer. And it may be, and I found this certainly in my experience, that you probably need to make very minor adjustments depending on the filament for your Z offset. So I don't really recommend doing it there. So if we go into the actual process settings, and let's have a look at this. We've got our first layer height is, well, our primary layer height is 0.2 millimeters, and our first layer height is 100%, i.e. also 0.2 millimeters. Now if we go into the G-code tab, and down at the bottom here, global G-code offsets is exactly what we want to do. And you can basically set, you know, a further offset for the Z-axis. So in our situation, we eventually figured out that we were 0.15 millimeters too high, so we would end up putting minus 0.15 in here, and when we then run the G-code, it will make that offset, and it will take basically 0.15 millimeters off of the first layer G-code height. Obviously subsequent heights really don't matter because it knew where the first one was, so the next layer is going to be, in this case, 0.2 millimeters above that. That's not an issue. We're only dealing with the first layer here. So these are the places in these two slices at least that you can make that tweaking. But like I just said a minute ago, it really is a sort of iteration of trial and error. You're going to try it a bit and you know, tweak it a bit, and then eventually you'll probably end up with a happy situation. There is, however, a caveat, and you might have noticed that all the way along in my slides I've been calling or referring to this as the random method, and I consider it random because we have a piece of paper or a folded piece of paper or whatever it is of an unknown height. And the way that we manage to end up getting that to work out is by going through these offsets in the slicer or wherever you choose to do it, and gradually tweaking them until it works, which is effectively a random way of doing it, trial and error. But that's fine. It's one way of doing it, and it's certainly the way that I did it to begin with. It is a little bit random, but there you go. There is a bigger issue though, and let's have a look at that next. To take a look at this issue that we still have potentially remaining, let's take a look at a sort of graphical representation of where we are at the moment. So basically the z-axis is going to home, which we've already done, and now it's going to start moving down to the position to print the first layer. Now with our first layer height set to 0.2 millimeters and our Z offset in the slicer set to minus 0.15, what it's actually going to do is it's going to set it to 0.05 millimeters above G-code 0, which will end us up at 0.2 millimeters from the bed. Perfect. And it's going to go away and start doing our print, and happy days. But let's imagine for a minute, and let's sort of swap this out, and let's say that we're now going to make a print with a 0.1 millimeter layer height and 100% or 0.1 millimeter first layer also. So with all other things being equal and our first layer set at 0.1 millimeters, with the Z offset in the slicer settings at minus 0.15, it's going to try and move us down to minus 0.05 millimeters from G-code 0. However, there's a bit of an issue because, as you can see, this will try and push us below the actual G-code 0 point. And as we've set up for good safety reasons a security feature to stop the nozzle being moved below 0, it won't do that. It will just literally go down to 0 and it will stay there, but it's probably not really going to show you in any way, and you'll be left scratching your head why that doesn't really look like 0.1 millimeters above the bed for my first layer. So you'll probably go back into the slicer and put a little bit more Z offset in, and you'll be going, this is strange, nothing's happening. And what you could do, of course, to get around this problem is go back into the firmware and take off whichever parameter it is in your firmware. In the case of Marlin, it is min software end stops. If you turn that on, it will allow it to go below 0. However, it will allow it to go below 0 at any point. And yeah, I don't really recommend that, because sooner or later you are going to give an instruction unknowingly to push the nozzle into the bed. So what do we do? Well, I'll tell you what I did, and that's about all I can say. For me, I think we should set the actual G-code 0 point to a point that is as low as, or a little bit lower than you are ever going to want to print a layer or a first layer. So, you know, I can't see that I'm ever going to print a first layer below, let's say, 0.08 millimeters. So I'm going to set it so that my nozzle is 0.05 millimeters above the actual print bed, and have that as my G-code 0. To do this, I'm going to use some feeler gauges, and yeah, it may be, you know, I know all those guys out there saying, oh, you just need a piece of paper. Well, you know, feeler gauges, they don't really cost that much money, and it's probably worth it in the end. So what I'm doing here is the same exercise that we did with the paper, but rather than using a paper, I'm using a 0.05 millimeter feeler gauge, and using the LCD to step it down until we get to that point. Bear in mind, in order to do this, you will have to have disabled that min software end stops value, otherwise you won't be able to jog the Z-axis down to below where you've already got it. Now, of course, you could also take the sort of approach of, well, let's set G-code 0 at actual 00, like just touching the top of the bed. But I don't think that's a great idea. You know, when the machine's zeroed, I don't really want it touching the bed, because if you then, you know, heat the nozzle up, or, you know, you move it around slightly without realizing, any type of warpage in your bed is going to cause it to grind. So anyway, yeah, we basically repeat exactly the same exercise like we did with the paper, but now with a feeler gauge at 0.05, and we can probably go back in and sort of quite comfortably into our slicer settings where we've got Z offset there, set that to 0.05, and yeah, let's have a look in the simulation of what we've got now. So the nozzle moves down to the height at which is going to print the first layer, and due to our, you know, 0.1 mil layer height that we want in this case, and our 0.05 offset, we know that it's going to move down to 0.05 away from G-code 0, which puts us at 0.1 away from the bed, and everything is good again.
And we could in fact push this all the way down to 0.05, which personally speaking, my first layers are never going to be that thin. And yeah, that's my clear as mud explanation on it. So let's go back up top and wrap this thing up.
So there you go. There is potentially, I would imagine, the longest explanation of Z offset that is available on the internet. And I hope that it clarifies rather than further confuses what these things do in people's minds. But the reality is that actually it's only going to take you maybe 5 minutes to do this job once you know what's going on. And that's kind of the point behind it. Once you know what these things are doing, then it's relatively easy to set things up for yourself. So in the next video, I'm going to be discussing another subject that I've been asked about by at least one person. And that is to do with your sort of starting and ending G-code. Now this really is dependent on what your printer is, what your filaments are, but also quite a lot of sort of personal taste in what you want to happen. So I can't really, you know, I can give you what I'm using, but whether that's right for you or not is, well, debatable. But what I can do is I can go through the things that you'll probably need in there, some of the things you might need in there, what I've got and why, and hopefully from that it'll give you, you know, an idea about what you might want, and we'll go through that in the next video.